this is something similar to serial port communication, which is synchronous one. When we are going to do an asynchronous one, let us try the program for asynchronous communication, and then we'll come back to this. Okay, now for that we made some ready-made program before to work with. So this is that one. Let me explain the program first. As usual, we have to set these configuration bits. After that, we have to include the library. Then we have to define our crystal oscillator frequency. You can ask me a question why we didn't define it for flag toggling, because it is we are not going to use oscillator clock during flag toggling. That's why we didn't do that. After that, I think here is an interrupt service routine. We don't need to bother about that. Let me directly come to the main. These are the different initialization that we have to do. Here, forget about these things. These are related to the timer. Here we have a TRISC bits. What we are actually doing, we are saying the bit TRISC port to C 6th pin is an output pin. Port to C 7th pin is an input pin. Because only then the transmission and reception will work. After that, we disable all interrupts. When you are trying to configure certain things, try to disable all interrupts in your program. If you don't do that, while you are configuring, you may get an interrupt. When that interrupt occurs, automatically the program counter will be mapped with the interrupt vector, which is 04, program memory address 04. So that will lead additional confusions. So whenever you want to do certain configuration, set your disable all interrupts. That is the first step that we have to do. After that, we are setting SPPRG. SPPRG is baud rate generator register. To that, we have to load appropriate value. We are loading 81 here. Why? As per this data sheet, yesterday we had seen, right now. Yeah. When you select baud rate as high, for 9600, it is decimal 129. Decimal 129 is equivalent to X81. Right now. After that, we clear this particular TXSTA. TXSTA is transmit status register. Right? We clear that to 0. Actually, we initially clear them all, and then we set certain things. From my view, we can do that before doing this. Before setting, even then it will work. We'll do as per the flow that is explained in the sheet. They clear that one, and then we set the baud rate high bit to 1. That is part of TXSTA, and then the sync bit to 0. When we make sync bit to 0, we configure that as an asynchronous communication. Then we clear receive status register. In that, we enable serial port. we enable receive interrupt as well as transmit interrupts. We enable both. Actually, we are using an interrupts, that's why we are doing it. If you are not using it, we no need to do that. And then there is a RCSTA bit. In that, we enable continuous receive enable bit. That should be set to 1 in order to receive it. After that, we enable the global interrupts, peripheral interrupts, and then the transmit interrupts. Also, we enable the transmission. The enable transmission should happen at the very end. Right now. After that, this is for interrupt enable interrupt function. We no need to bother about it because we are not going to use interrupt initially. Then we wait for infinite loop. What this will do when you actually this is this one will simply accept txt equivalent to row, but the tx register we are not transmitting anything here now. So from my view, it will simply receive incoming bits from the PC and then where it stores that RCSTA. Okay, those were done in the interrupt service routine. In this case, we are not going to use it. We will do that in our main itself. See, actually, if there is a transmit interrupt flag is set and then these 2 bits are 1, then we clear that one. That is what we are doing here. But I don't think we are doing any valid. Yes. We are transmitting 65 to just to check that this is a test program. Let us write the program that simply gets some things from us and will echo it back to us. So whatever that we are typing in the laptop should go to the microcontroller. After receiving it successfully, microcontroller should send that back to us. Our laptop should receive it and have to show that to us. This is what we are trying to do. For that, how we have to write program. So what I do, this is what our old program. I just want to make a copy of it. So just file, save as. Under embedded C, we have IO port right now. So I call this one as SCI and save that. All right. After that, we remove this warning and telltale C. And I add interesting. What happened to that file where we saved it? IO port save as file. Embedded C. Okay, probably we have to save it under this. Right now. So after doing it, we just add SCI.c. Perfect. Here we are going to declare a function called init serial port. That is a function. We can even call that a void one. It is just a function prototype. After that, here we are going to define. When you look at this file, very first step that they have done is they are configuring the pins for serial communication, right? Those are part of TRISC register, right? So TRISC register in that bit 6 right now. So what we can say, TRISC is equal to TRISC we have to set only that bit now, meaning we have to set sixth bit TRISC. Port 3 data direction register, right? Bit 6 is the seventh bit. So when I want to set the seventh bit, as per this program, we have to set that bit to 0, right? So and it with 1 1 0 1 1 and then 1 1 1 1. This will make only when I add it with 1011. 1010 is 10, 1011 is 11, right? Which is BF. When you add it with BF, that particular sixth bit will become 0 and remaining bit will be as such, right now. So for that, what I do, TRISC equivalent to TRISC and with 0x BF. You can ask me a question. Why don't we just say TRISC bits and then bit 6 equal to 0? We can do like that. But what happens is it creates problem. It is throwing error. Let's say, let me save this and I compile it. If it works fine, it's great. But they are throwing error nowadays. Let us check whether they are not, whether they throw error or don't throw error. This is very easy to work with, but I think this logic is not working. So meanwhile, let me configure 4C in pin 6C. I believe it's okay. I believe. Yes. Undefined symbol delay. That is what the problem. So let me comment that. After that, okay, I believe we don't get any error now. We can go like that. But I don't know why we got error on that day. No error. Perfect. So I just set that pin value to configure pin as 4 to C, pin 7 as output pin, meaning which is TX pin as per the pin diagram. See, if you look at the pin diagram, right, 40 pin dip. See, RC6 is the TX transmission, RC7 is the reception, right? So we configure that first. TRI C bits is 7 is equal to 1. So which means that we are configuring that as a input. Output pin, otherwise we can even say this is a TX pin. That would be more appropriate. RX pin. Right. After doing this, what is the next step? Let us follow the data sheet. What data sheet speaks about this? The steps they have told, no? These are the steps. Initialize SPBRG register for appropriate baud rate. Right? If high speed baud rate is desired, set baud rate high. Use at baud rate. So first of all, we have to decide whether we are going to go for a baud rate high or baud rate low method. So we are going to use baud rate high method. So BRG high is part of which register? Which register? I believe what region is selected. BRG register for appropriate. Initialize the SP BRG register appropriate baud rate. If the high speed baud rate is desired, set bit BRGH. BRGH is the TX STA, I believe, if I am not wrong. Yeah, this bit, right. So first, after doing this, what I do, TX STA bits dot equal to 1. That we are setting first. After that, they are asking us to set excuse me. So here is the steps, right? This is asynchronous reception, asynchronous transmission. So SPPRG is equal to 0x 81. Configure baud rate as 9600. Right. Then select high baud rate. Right. That is also done. After doing that, enable asynchronous serial port by clearing the sync and setting the bit SPN. So we have to enable asynchronous serial port by clearing sync bit and setting SPN. I believe both of them are part of TXSTA if I'm not wrong. Sync SPN. I think it is part of RCSTA. Spen. And then what other things that they told us? Sync is part of TXSTA. So first what I say, TXSTA bits dot sync equal to 0, meaning it is not a synchronous communication. After that, RCSTA, here serial port enable. That is the next step that we have to do. We configured the pin, we configured the baud rate method, then we configured actual baud rate. Then we are configuring, see, this is for asynchronous. Asynchronous, what is the problem? Then enable serial port. Right. Right. So we enabled the pins, then we configure the baud rate, then we enable asynchronous communication. We are also enable a serial port. Once that is done, what is next step that they are saying? If interrupts are desired, set enable bit TXIE. We are not going to enable these what do you mean to say, interrupts. Now we are not at all going to use any interrupts, so that what we do, this TXIE is part of PIE1, I believe, if I'm not wrong, peripheral interrupt PIE bits, PIE1 bits. In that TXIE is equal to 0. We are not enabling anything. And then if 9 bit is enabled, set transmit bit TX9. Okay, there is a TX9 bit is there that we have to set if we are going for 9-bit communication, 9-bit transmission. We are not going to use it. If that is the case, we have to set that to 0. So it is part of TXSTA, if I am not wrong, TXSTA bits dot TX9 is equal to 0 because it is not a 9-bit communication. Enable transmission by setting the bit TXEN, which is also set bit TXIN. We are going to enable the transmission. How to enable the transmission? Enable the transmission by setting the bits TXEN, which will also set TXIF. Okay, so TXEN is part of TXSTA, I believe. So enable transmission by betting TXEN, which will also set TXIF. So I go back here, TXSTA bits dot TX enable equal to 1, meaning I simply enable the transmission. Right? If 9-bit is transmission selected, 9th bit should be loaded to 1 because we are not going to use 9-bit transmission, so we ignore that. Load data to the TX register and start transmission. Right? If using, anyhow, we are going to do that. So I just with this, the initialization is over. So init serial port. In my main function, I simply call this one. Right? Whenever I enter this particular function, I will call, whenever I enter main, I call initial serial port, meaning I will initialize the serial port first. After initializing the serial port, I am going to transmit something like some word to denote, to some byte to denote there is a transmission happens. What bit that we can choose? 65 in decimal, which is A. ASCII wise 65, right? So let me give that value. TX REG is equal to 65 in decimal. Then I just write it. I have written it to TX register and waiting. Right. Only one time that will write. After that it will wait. That is, we are going to write it again and again. To do that, what we have to do? We have to find out some method. So TXREG register, we have written 65. Even let us check whether this is working. After initializing the serial port, we just load TX register with 65. That will simply send that data out. If a serial communication is enabled and moment I write a data to TX register, that will be transmitted. We need some program from the PC side to receive and show that value. For that, we have a famous program called Teraterm, which is the advanced version of hyperterminal that we had before in the Windows. So we are going to use that to see whether are we able to receive the data transmitted by the microcontroller without any issue. Now we have only implemented the transmission part. We have not implemented any reception part. As we are not going to enable any interrupts, we can make interrupt control register int con is equal to 0, meaning we disable all interrupts. That is what we have done here as well. Int con value equal to 0 right now. That's it. After doing it, how the transmission works, here we have USAR transmitter block diagram shown in the figure. Heart of the transmitter is transmit shift register. When you write to TX register, automatically it will go to TSR. The shift register obtain its data from read write transmit buffer TX register. TX register is loaded with the data in software. So we have loaded 65 to that. TSR register is not loaded until the stop bit has been transmitted from the previous load. So once we loaded some data, it will be copied to TSR and the TSR will do a shifting. While the TSR is shifting, a new word, even if you write something to TX REG, that won't be written to TSR. It will wait because TSR is currently shifting it, shifting previously loaded value. As soon as the stop bit is transmitted, TSR is loaded with the new data from the TX register. If we have something there, that will be loaded again. Once TX registers transfer the data to TSR register, right? The TX register is empty. The moment it shift the data to a TSR register, it becomes empty. And the flag bit TXIF is set. So if it is empty, no, that bit will be set. This interrupt can be enabled, disabled by setting clearing TXIE. This interrupt can be enabled by setting the enable bit TXIE in this particular thing. The flag bit TXIF will be set regardless of state of TXIE, meaning that whether you enable the interrupt or not, that doesn't matter. Moment you write something to TX register, they will enable. Moment the TX register is empty, this particular bit will be set to 1, so that we can monitor that bit. Where in this infinite loop right now, while true we are doing, right? So what we do, while what is that? TX STA bits dot TXIF. Okay, I don't think it is part of this. TXIF. Okay. If the TX REG register empty and the flag bit TXIF PIR1 fourth bit, while PIR1 dot bits dot TXIF equal to while TXIF is 1, meaning empty, we can say not empty means while it is 0. While it is 0, it is not empty. If it is empty, you have to write another word. That's all. So that after they load it, they come here, they check for whether it is empty. If it is empty, they load it. After that, it will be transmitted. Then they come and wait for till it becomes empty. If it is empty, they will come again and load a value. Let's see whether this works. That's all. The program is ready now. So only the transmitter part is implemented. Let us see whether it works. Okay. Typo error here. Line number. Perfect. File is ready now. So let us flash it. For that I have to connect. Is the old new one? Yes, it is new one. What we have here is the old one. Yeah, no wrong. Both looks new. I think this is old. This is new. Let me connect that. Connected. Yeah. So it detects that one. After that, what I do, I just import. Probably we have to erase the previous program. Just I read it. Okay, it has some programs here, and erase that. I mean to do erase. After that, write. Perfect. Then I download my new X. Right. Then I write it. Oh, I believe we changed the name. Is it the same one? It appears to me very small. Let me check. Let me check the timing. File in effects. This is done 7:49. Yeah, then it is latest only. Right. After that, write it. Perfect. Now it is time to connect that to board. Let me connect that to board. Okay, connected to the board now. But okay, if I turn it on, if I run this micro program, I will get A from the microcontroller. It should be received by the this laptop now. So what is the link between microcontroller board and the computer? We have to use a serial communication cable. Only then we can receive and see the data. So I have one here. Let me, I think here I will communicate with the problem here is here the ground is not there. Why the ground? So I think after this, let me connect here and then need one more thing. I don't know where I put that. So if I turn the microcontroller on, it will do the transmission. But problem here is we have to receive it from the board. For that,
Sir, from the multimeter, we can check, sir, like changing
no.
the voltage.
We can no. We have either we have to use a CRO because it
Okay.
is transmitting, and then we can see it. We can receive and see. The problem here is we need to have a cable which is connecting the motherboard and the laptop. The cable I have, but problem is we need to set up a ground. The ground is missing. Give me a sec. Let me try this way. Can use. I got that one. All right. Get it? I put that ground. And very interesting. We need a female to male. Okay. No, it's not going. Hmm. Okay. Come on. Okay. Connected. Then we have that one connected here. Right. Then I turn the microcontroller board on. Now it is time to start Teratom. So here we have Teratom. Right here, COM3, right? Okay, can't open COM3, not found. Why? Mm, come on. So no port is detected. You should detect the port. Device manager. Right. So here, port is okay. We need a driver. Give me a sec. Let me install a driver. Tablet driver file successfully copied. You must restart the computer. Restart later. Maybe I want restarting. Let me remove this and connect it back. Interesting. It appears to me we have to restart.